Hello, everyone. I hope you guys are having an awesome day so far. Thursday. I love Thursdays because it leads into Friday. All right. So today we are doing a melting point lab. Okay. And we're melting ice. So we're using water. Okay. Now, what I'm going to do is I'm going to show you the data. Okay. The data we got so that you are able to graph and graph the data. So you can get practice of seeing what a melting curve and boiling point curve looks like, okay? So I'm going to grab a piece of paper here real quick, and we will get going. All right. So I got my lab paper here. All right, let's see. Okay, so this is the data, okay? This is the data you got. All right, so we had solid to liquid, and then it started to boil, so it should actually probably be liquid to gas through here, okay? So I want you to copy this data down, all right? You can find this assignment on the classwork tab, okay? The classwork tab, copy this data down, okay? And if you need to pause the video, you can. All right, but I am going to move on. All right, so on the back of this page, it says graph the data, okay? So number one says create a line graph using the data collected during this lab. Time should be on the x-axis. So time is in minutes, okay? Time is minutes, okay? Now, what I did was every other line I went one. So I skipped a line, one, skip a line, two, skip a line, three, skip a line, four, skip a line, five, all the way to 20. Okay, and if you need to pause the video, you can do so. Going up, I went by 5. So the first line, 5, 10, 15, 20, 25, 30, 35, 40, each line. Okay, and that was in temperatures of degrees Celsius. Okay, so that's how you should set up the graph. Okay, hopefully that makes a little bit of sense. And you're going to graph the data. Okay, graph the data. Then after that, what you're going to do, or I'm going to go over something real quick. So here, we're going to be talking about the different states of matter. So you know solid, liquid, gas. As you move from solid to liquid, you increase energy. Okay, and as you go from liquid to gas, you also increase energy. All right, so what that means for the particles, I'm going to try to move that. Oh. There we go. I clicked out of it. Is that on a solid, your particles are very close to each other. Right? They're very close to each other, if you can see what I'm drawing down here. On a liquid, they're kind of spread out, and they get to move a little bit. So this is very dense. This is less dense, right? They can move a little bit before hitting each other. These can't move at all. All right? And then there's a few that's like going crazy. They eventually go anywhere and everywhere, right? All right, so these are all the different particles. Now, however, water's a little differently. As you know, ice floats, which means ice is less dense than the water, right? So this is actually the solid, and this only applies to water. The rest is opposite. This would be solid. But since water is very unique, this is the liquid, and this is the gas up here. Okay, so when it says describe what's happening to the water particles, all right, the particles lose energy and then they gain a ton of energy. All right, and then the spacing gets a little bit closer and then it gets very spread out. Okay, so hopefully that kind of made sense. All right. Now, temperature. So temperature is actually, in chemistry, it's a measure of kinetic energy. All right. It's not the measure of heat, it's the measure of energy. So the higher the temperature, the higher the energy. Okay. Now there's two new terms we're going to learn. One is endothermic. All right. Hopefully you can see that. Endothermic means adding heat. You add heat. All right. So when you melt, all right, well, that makes sense. A solid melts to a liquid when you add heat. A liquid evaporates to a gas when you add heat. The other is sublimation. Okay. So that should help you answer question number 4. Question number 4. Now, 4A, did all 3 of these phases change during this lab? No, we only saw melting and evaporation. Okay, we only saw 2 of them, melting and evaporation. Okay, and then the exo means exiting heat. I think exo, exit. All right, you remove heat. All right, and that's freezing, deposition, and condensation. Now, this is what a graph should look like. So you should kind of have a flat line, should increase in a flat line and increase at the end a little bit. Maybe not. You might finish on a flat line, okay? Now, what that means is this first flat line is your melting point, okay? What is the melting point? The second flat line is the boiling point, okay? So hopefully that helps answer number 3. All right, label the melting point and boiling point on the graph. All right. All right, hopefully that starts to make sense a little bit. All right, you get to see a little bit of what each graph kind of looks like for different points. So after graphing that, what I want you to do is I want you to take a picture of this. I want you to take a picture of this side of the paper. Okay, I want to see the graph. I want to see these answers. Okay, when you are done, shoot me an email. All right. I'm not creating a Google assignment for this. Shoot me an email and I will grade it through the email. Okay. Does that sound good? If you guys have any questions, let me know. If not, I hope you guys have an awesome day and we will see you tomorrow.